All right, scholars, and we are back. Let's see. So here we are in our last of the new material. So after this section, going forward, we'll just be using the remaining time for review. I know that on my end, again, I do need to create an exam 3 and a final. I'm tempted to just go ahead and make everything available. I'm really tempted to. I know it's a little bit early. And I know I'll go ahead and at least make exam 3 available. Final, I might wait a week or so. Maybe like until after the holiday, the Thanksgiving break, right? Okay. And so this is section 12.6, scatter plots, correlation and regression lines. Okay. A few learning objectives here. 1, make a scatter plot for a table of data items. 2, interpret information given in a scatter plot. 3, compute the correlation coefficient. 4, write the equation of the regression line. 5, use a sample's correlation coefficient to determine whether there is a correlation in the population. Okay, let's see how this unfolds. So a scatter plot is a collection of data points, one data point per person or object. It can be used to determine whether two quantities are related. Correlation is a clear relationship between two quantities. It's used to determine if there is a relationship between two variables, and if so, the strength and the direction of that relationship. The scatter plot shows a downward trend among the data points, with some exceptions. People with increased education tend to have a lower score on the test measuring prejudice. People with increased education tend to have a lower score. What is this? Years of education score on the test measuring prejudice. People with increased education tend to have a lower score on the test measuring prejudice. Okay. So they're trying to say there's a correlation between education and prejudice. Okay. And this is the data here is showing the less educated you are. I can't even get my words out. I'm talking about education. I don't know. My brain is off, right? We're approaching the holiday. We're approaching the Christmas holiday. This happens to me every semester. Like as we get to the end, my brain's like, yep, we're done. That's close enough. We're gonna go ahead and go on vacation. So we're just gonna leave the rest of you to kind of fend for yourself. That's what's going on with me right? But basically, it's saying that the less educated someone is, the more likely they are to be prejudiced, right? That's just based on this data. I'm not saying if this data is accurate or not. Let me see. Although the scatter plot shows a correlation between education and prejudice, we cannot conclude that increased education causes a person's level of prejudice to decrease. Okay. The correlation could be simply a coincidence. Yeah, because that's what I was feeling. I was like, I mean, yeah, you could say that, but there's always exceptions to the rule, right? Like you can have somebody that hadn't had any education, but then, they could be a saint, you know. So one thing about statistics, generally speaking, it does not apply to the individual, right? Statistically speaking, so and so might happen, but that doesn't necessarily apply to the individual. Let me see. The correlation could be simply a coincidence. Education usually involves classrooms with a variety of different kinds of people. Increased exposure to diversity in the classroom might be an underlying cause. Education requires people to look at new ideas and see things in different ways. Thus, education causes one to be more tolerant and less prejudiced. Okay, let's see what else we got. So a regression line is a line that best fits the data points in a scatter plot. So given a scatter plot, we're trying to draw a line that gets as close to as many of the points as possible, right? So the correlation coefficient, designated by R, is a measure that is used to describe the strength and direction of a relationship between variables whose data point lie on or near a line. The relationship is positively correlated if they tend to increase or decrease together. It's negatively correlated if one variable tends to decrease while the other increases. Okay. So positive correlation, generally, I think I want to say has a positive slope as you trace it left to right. A negative correlation should have a negative slope as you trace it left to right. As one increases, the other decreases. Perfect positive correlation in which all points lie precisely on the regression line that rises from the left to the right. Perfect negative correlation in which all points lie on the scatter plot lie precisely on the regression line that falls from the left to the right. Okay. So in that first example, that's an example of, this one, I don't know if we're going to calculate it. It would be nice to calculate it. But there's this like long drawn out formula. We'll see how it unfolds. So with this first example, that's an example on perfect positive correlation, right? So notice as we trace it left to right, it's increasing and they all lie on the same line. This has part B has a strong positive correlation. All the points are not on the same line, but they're really close. Now these are scattered. This has a weak positive correlation, right? So as we look at the line of best fit, the data points are kind of far away, right? Kind of spread around. This has no correlation at all, right? It doesn't seem like it doesn't seem like it has a trend one way or another. They're just completely scattered. And then E is an example of moderate to weak negative correlation. We do the line of best fit. The points are still kind of scattered, but they are tending to like a negative correlation. This is a strong negative correlation. And then this is a perfect negative correlation. Okay. Okay, let's see what else do we have. You all look like you're okay. Testing, yeah. Let's keep going. Okay, here it is. So the following formula is used to calculate the correlation coefficient R. Right. So I think we mentioned this symbol, right? This is called summation. It's the Greek letter sigma. It just means add up your results, right? N is going to be our number of data points. So we have like x1 times y1 plus x2 times y2 plus, you keep going until you get through all the ordered pairs. Add up all your x's. This one means add up all your y's. This one is saying if you take each x value and square it, and then this is going to be the sum of the squares minus the square of the sum. So this one is we add up all our x values first, and then whatever answer we get, we square it, right? We're gonna calculate this. More than likely, I'll use a spreadsheet, right? I feel like this will be easiest to do. Now, I think it can do it automatically. We'll do it manually, and we'll see if we can find a way to do it automatically I'm going to use Mac iOS numbers. It's similar to Excel. If you're going to work in Excel on a spreadsheet, you just have to like do a Google search and learn how to adjust. Like you have to do a Google search for what you're trying to do, right? So on and so on. The main takeaway with this is that this symbol just means add up your results. And the X and Y corresponds to the X coordinate and the Y coordinate of each ordered pair. Okay, let's see. I feel like we should get a copy of that. So in the formula, the number of data points, right? Our N is the number of data points. The sum of the X values, sum of the Y values, sum of the products of the X and the Y in each pair, the sum of the squares, and the square of the sum. Okay, let's keep going. So shown below are the data involving the number of years of schools X completed by 10 randomly selected people and their scores on the test measuring prejudice. Okay, are we missing something? We surely are. Let's back up. This is slide 14. Okay, here it is. So respondent A through J, years of education with their score on the prejudice test. Okay, so we have these set of ordered pairs. Okay, it says determine the correlation coefficient between the years of education and the scores on the prejudice test. Okay, let me start by getting a copy of this formula. And again, like many of these devices will calculate this automatically. Like I'm pretty sure there's a function that we can find that'll crunch this number automatically based on some data. I'm going to drop that right here. Okay, so we have a copy of the regression formula. I'm just using it as a reference. And I think I'm going to do this in a spreadsheet. So let me start by getting a copy of this data. Kind of throwing off my recording a bit. Let me think about it. If I go like this, I just want to, nope, get out of this. Okay, I just don't want to make sure I'm not showing like anybody's grades or anything. That's what I was trying to be quick. We're just going to do a blank slide. Let me align it with our slides. And what I'll do, I'm just going to make a table pulling a copy of the data, right? So like in our first column, I'm going to translate it so it's vertical. We have our respondent. I can't see that. Let me zoom in so I can at least show the 3 columns. Respondent, and then we're going to have the years of education. Oops. And then we have the score on the prejudice test. Score. Again, this is our Y value. These are X values. Okay. Let's go like that. And then what I'll do, notice this is looking a little bit weird, but we're gonna go with it. I'm gonna drop it down just a little bit. I'm gonna shrink that and expand this so we can see this a little bit better. Maybe I can zoom in just a little bit. Okay, and then let me expand this. And then if I go to column, come on. And what I want to do, where is it? Fit content, right? There we go, that's better. Okay. So we said A through J. So let me see, A and then B. And then what I'm going to do is use a formula to continue the pattern. It should go through J. We're just going to go all the way until we get to J. Okay. Now for A, our X, let me see. So 12, 5, 14, let me see, 12, 5, 14, 13, 8, 10, 13, 8, 10, 16, 11, 12, 4, 16, 11, 12, and 4. Okay. Come on, there you go. And then 1, 7, 2, 1, 7, 2, 3, 5, 4, 3, 5, 4, 1, 2, 3, 10, 1, 2, 3, 10. Okay. Okay. So now I'm using this formula here as a reference. Let me see. So we're gonna find each part. I see a total of like, let's see, sum of x's, x times y, 1, 2, 3, 4. Okay. So in my first column, I'm just going to do my x times my y. So I'm just going to abbreviate it as xy. So I'm just going to say x times y. No, it keeps autocorrecting. Xy. I just want xy. Thank you. All right, we'll come back and calculate that. Then we're going to find the sum. We're going to incorporate that into our formula. We'll come back for that in just a moment. We can find the sum of the x's. So maybe here we'll put total. All right, we'll come back and find that. We'll find the sum of the x's, sum of the y's. We're also going to need x squared. Let's see, so x squared. We're also going to need y squared. Okay. And let me be consistent. X squared. It keeps like auto correcting things. Y squared. Okay. Okay. We got our x squared. We got our y squared. Okay. So now, for instance, when I want to do my x times my y, I'm going to activate the formula mode or the equation, right? So I'm clicking on the cell, and then I'm gonna hit equals, right? When I hit equals, that puts it into like a formula mode where you can do calculations, right? So then I want to say, if I'm saying x times y, I'm saying this cell times this cell, right? Then I hit enter, and it's basically said, 12 times 1 is 12. 5 times 7 Now I'm just going to copy that formula all the way down. All right. So the next one should be what? 35, 28, so on and so on. Right. So it's basically multiplying those. Right. So you can see, you know, which cells is referencing. So then here I want to say x squared. So this is going to be equal to this cell squared. I'm going to say to the power of 2. And just hit enter. Let me see. Oh, yeah, to the power of 2. I don't know why. It keeps auto-correcting. Okay. And I'll copy that going down in just a moment. And this one is going to be equal to y squared. So this cell to the power 2. No, don't autocorrect. Thank you. Okay. So then we're going to copy those formulas down for each row, right? It's just going to continue the pattern for each corresponding row, right? So then, right, we got our x squareds and our y squareds, right? We just squared those corresponding entries. Right. I was trying not to shrink it down, but you know, we'll come back to that. Okay. So here, this row I'm going to say is going to be the sum of all the entries, right? The totals. So let's see. This is going to be equal to, I'm just going to say the sum, and I wanted to add up from here to here. I just wanted to add all those up. We get this result, right? And I'm going to copy that formula for each column because at some point we're going to need the sum of each of those columns, right? Right. So I'm just telling it to add up all those results for each column. Okay, I think we're okay. It looks good. I'm going to go with it. Okay. So now we have the total of each column. So now let's calculate our regression line. So our correlation coefficient. Come on, stop doing that. Thank you. Okay. So now I'm going to do a formula, right? This is going to be equal to, now it says we should have, let me make sure I'm doing this. I did it the other day. I just want to make sure. I'm going to hit equals count. And I wanted to count these. Should be 10. Okay, let me see. I think it's a different formula other than count. Count, I think A for like alphanumeric or something like that. And let's see, that should be 10. There it is. Okay, so we'll use that one. Okay, so we'll count A. Okay, so now I'm just going to type in the formula, right? So I'm going to put equals. Now, first I'm going to isolate my numerator. My numerator, we have n, so I'm going to capture that by saying count A, right? And that's basically counting, like if it has text in that, and it should be 10, right? We have a total of 10 entries. I'm just trying to get something that's a little bit dynamic where we capture the 10, all right? So now we've captured our n, and we're going to say times, so I'm going to do another set of parentheses, the sum of x times y. Now we already have that right here. So we want this entry. Okay. Okay. So now this does take some organization. I'm going to say minus the sum of my x's is here times the sum of my y's right here. Okay. That should be, wait a minute. And I think I need another parentheses. Count. No, I think we're okay. Yeah, so that we finished the numerator. Okay, so now I'm going to say divided by. Now I'm going to do a separate set of parentheses for the denominator. And first we have the square root. Is there a square root? Let me see. So for the square root, I'm just going to do a blank set of parentheses, and I'm going to say to the power of 1/2 to capture the square root. Okay. So now inside the square root, we have n, so I need to do count A again. And it's basically going to be the same thing. Okay. So there's our n. Now we want to say n times the sum of x squares. Now we have the sum of the x squares already right here. So we want to say n times, I'm going to put a multiplication. Sum of the x squares, sum of the squares is here. Okay. Then we're going to say minus, this is still inside the square root, the square of the sums. So we're going to take the sum of x's, which is this purple on the left, and that result, we're going to square it. Yeah, this one. We want to say that squared. Okay. Okay. So we finished the first square root. Then I'm going to say times. Now we're going to do another square root to the power of 1/2. Okay. And now this is us doing it manually. I think it'll do it automatically. After we finish this, we're going to see if we can find a faster, more simple way to do this, because I think there is one. Just give me a moment. So our n, we're going to do count A in this case. Count A of this again. Oh, good. Okay. Okay. Count A. That gives us our n. We want to say times the sum of the squares. So we're adding up our y squares, which is going to be this one right here. Okay. Still within that square root, we're going to say minus the square of the sums, right? So we're going to take the sum of our y's, which is this guy, and we're going to square that result to the power of 2. Okay. We close off that square root and we close off the denominator. We're going to cross our fingers. Hopefully we typed everything properly. Hit enter. We did not. Let's see, what are we missing? Syntax error. Let me see. I'm gonna have to go through it. I think I'm missing some multiplication. That might be. Let me try. Let's see. Put a multiplication there. Let's see if that fixes it. Oh, okay. So we it didn't know to multiply. I was missing a multiplication symbol. Okay. So we got this correlation coefficient. We're getting that it's almost a perfect negative correlation. We get negative 0.92. Now let me see if I can do it automatically. Regression, what is this? Correlation coefficient. Let me see if I hit equals. Let me see if it was y values and the x values. Correl. Let me see what this is. Y values are here. Right here. Okay, I'm gonna hit comma. My x values are here. Keep missing that first one. Okay, let's see if it does it automatically. Oh, it did. Wow, I just learned something. I think that was my first time ever doing it. So we did it manually, right? And there was actually a formula that does it automatically. But I went on and did it manually just as like an exercise, right? So we we found all the different parts, x times y, the sum of the x's, sum of the y's, sum of the squares, square of the sums, that kind of stuff. We found all those parts individually. Then we manually created a formula. But there was already a formula in the spreadsheet that would do it, right? So when I activated the formula in iOS numbers, it was called Correl, like correlation. I guess it's short for correlation or whatever, correlation coefficient. And then it was like there was a part that asked for the y value, so I just highlighted my y values. There was another part that asked for the x values, so I highlighted those, and then it got the exact same result, right? So we did it. We know how to do it manually and automatically. Additionally, I want to say the TI-83, the regular calculator we use, if we put this data in there, it'll do the same thing. It'll automatically spit out the correlation coefficient. I'm tempted to try it, but I think that was enough, right? So we got our correlation coefficient. We got a negative 0.92, which is almost a -1, right? which is a strong negative correlation. All right, let's see if we can restore this back to how it was. Hopefully this stuff is going to behave properly, right? So get back to where we left off. Somehow we lost our place. Okay, here we are. Okay, so when we did it, yep, see, this is exactly what we did. We had the x value, the y value, we did x times y, we did x squared, we did y squared. The final row was the sum of each column, right? We added everything up. And then we plugged in those different components into our formula. When we did it manually, we got the same result. We did it in a spreadsheet. On top of that, iOS numbers, a lot of these platforms already have that formula in there. That's a major one that's used in statistics. So it's actually already there, which we saw. Okay, that was interesting. Formula. So write an equation of the regression line by hand, y equals mx plus b. So then our slope is going to be given by the guy on the left, and our y-intercept is going to be given by the guy on the right. So we would have to go back and calculate all of that. I'm not going to do that right now, though. To find the regression line for the previous data, again, the slope formula, this is just something that you use. I don't expect you to commit this in memory. I just need you to know how to use it. So that way, if it ever shows up. I mean, we can do that formula, especially since we already have all those components. Let's go ahead and do it. Let me stop being lazy, all right? I'm always looking for some excuse to cut corners, but that does not, nope. And I see the time I'm trying to get you all out of here. Okay, we have a lot of this stuff already, right? So let's go ahead and calculate our slope. I guess we could just leave it as m, and our y-intercept. Okay. So now the slope formula, let me see, that's going to be equal to, now let me isolate my numerator by n. So we're going to say count a, because we're counting the text. Every time a cell has text in it, it says +1. And we got to remember to use multiplication. That's what threw us off last time. So we're going to say times. And then we got this the sum of x times y. So we already have that part. X times y here, so the sum is here. Okay. So we got n times that. Okay. Then we're going to say minus the sum of our x's times the sum of our y's. Sum of the x's is here, this cell, times the sum of our y's is this cell. Okay. Then we're going to say divided by, now the denominator, and we're still focusing on the slope right now. Count a. This right here, from here to here. Nope. Nope. Right, that's fine. Okay. We did count a times the sum of the squares. So we already have that. So times this cell right here. Okay. That looks fine. Then we're going to say minus the square of the sum. So the sum of the x's is here. We're going to square that, guy, so it's to the power of 2. Okay. So that should be our slope. And we're getting a slope of a negative 0.6, this number here. Okay, that's fine. So then for our b, that's going to be equal to, let me focus on the numerator. The sum of our y's is here. Okay. Minus, we got to use the slope, okay. So then minus this result, so minus this cell, times the sum of our x's, which is here. Okay. And then we're going to take that numerator and say divided by n, and the way we've been doing n is count a. count these guys from here to here. Okay. Okay, so now we get an expression for b. Y equals mx plus b. So then our function, the equation of our line should be y equals a negative 0.69x plus 11.01, right? So let's kind of just glance at it here. Negative 0.69 is correct. 11.0, no, we get 01, they get an 05. There's some rounding somewhere going on. That's the only reason it's a little off. So the equation of the regression line, we essentially got the same thing. The reason that's off is just because of some intermediate rounding somewhere. Usually that's what's going on. I think that in our formula, here, let me see. I think I can generate the number that they have. So in this formula for B, where we used that result for M, I'm going to round that result to, instead of doing it there, here, I want this result to be rounded. All right, so I'm going to do round. And I want to round this result for the slope. I want to round it to 2 decimal places. Okay. So then we should get our negative 0.69. Okay. And then for B, and then that's how they're getting it, right? So now because when they calculated B, they used the rounded result. So you can see now that it's off. And then when you round this result to 2 decimal places, that's how they're getting it. Again, usually when it's off like that, it's some rounding somewhere, right? And so that's what happened. Now if I round this guy to 2 decimal places, right? Now we get the same numbers that they have. Okay, cool. Cool beans. Nice, right? Okay, so we got it. So we did it. We took the data, we put it in a spreadsheet. We were able to generate the numbers, and that brings us right to the end. That's pretty cool. I mean, you might not find it interesting, but I do, right? In a previous example, we computed that R was a negative 0.92 for 10 objects, for 10 data points. Can we conclude that there is a negative correlation between the education and prejudice? Begin by taking the absolute value of the calculated correlation coefficient, which is 0.92, okay? Come on. Come on. My device is on attention. There we go. Okay. So according to the table, so this is table 12.18, 0.92 is greater than both of these values, 0.632, okay, and 0.765, right? So when n is 10, because our correlation coefficient, let's see, values for determining correlation in a population, we conclude that a correlation does exist between education and prejudice in the population. Because our correlation coefficient is higher than these guys. Let me see, it's greater than both of these values, 0.632 and 0.765, okay. We conclude that a correlation does exist between education and prejudice. Okay. All right, well, yeah, that's interesting. All right, ladies and gentlemen. So that officially brings us to the end of the new material. So from here on out, we'll be doing review. More than likely what I'll do is like I'll try to see how many sessions we have remaining, and I'll try to divvy up entire content for the semester, and I'll break it apart evenly, right? Like if we have 6 sessions remaining, I'll try to break up I'll try to break up all the data into 6 separate sessions, so then, within 6 sections, we would have reviewed everything. As we're doing the review, if you have questions about anything that's on My Open Math, if you just bring it during class, we can work on it together. Okay. On my end, I do want to create an exam 3 for you all, and exam 3 I think is going to be over chapter 8 on personal finance, chapter 11, and chapter 12. So I think that's probability and statistics, and then personal finance. And then the final, I think I need to create a final as well. And final is basically going to be a little bit of everything from the beginning to the end. Okay. I know I'm going to go ahead and make exam 3 available as soon as possible. The final, I'd rather wait until after the Thanksgiving holiday before I make that available. Are there any burning questions before we go our separate ways? Going once, going twice. Okay. All right, if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, take care. We'll meet back on Thursday, same time, same place. Take care. Peace.